Creepy crawly Jew or insect Jew is a red monster star. On the off chance that you put it where the sun is, it would stretch out to the circle of Jupiter. It's gigantic and entirely unsteady. It's going to detonate. These are among the greatest blasts of radio energy in the whole universe, creating more energy than a billion suns. As we ponder the sun, we know about its huge power and the energy it exudes all through our planetary group. This brilliant star, a blasting bundle of atomic combination, supports life on Earth and directs the cadence of our days and seasons. It is difficult to envision anything able to outperform our sun, yet past our own star lies a vast marvel that makes even the mightiest solar monsters appear irrelevant in comparison. Betelgeuse, Bug Jew, the red supergiant, defies explanation. With its huge width, sporadic throbs, and unusual conduct, this baffling star has interested space experts for centuries, presenting secrets that challenge our comprehension of stellar evolution. The star is a puzzle to researchers who are as yet concentrating on its power and potential. As they research this eminent star inside and out, they have found something unnerving. Join us on this journey as we delve into the star constellation Orion with the James Webb Telescope and explore how its appearance could change our understanding of the universe and its impact on the cosmos. This investigation vows to unveil new insights into the life cycle of stars and the dynamic processes governing their changes. Assuming you're keen on staying up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell to stay connected with us for additional exciting discoveries and cosmic insights. Although many people are unaware of this fact, it is possible to spot Betelgeuse in the night sky throughout the winter months in the northern hemisphere. This brilliant reddish star stands out even to the unaided eye, a beacon in the cold winter sky. Simply gaze toward the star constellation Orion and Canis Major to see this astonishing star in all its glory. Orion, often referred to as the Hunter, is one of the most unmistakable constellations, making Betelgeuse relatively easy to locate. There you can easily find the rosy-orange star that marks the upper left corner of the rectangular shape of the constellation. This distinct color and position make it an interesting object for stargazers and amateur astronomers alike. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked carefully at this star, you will have noticed that it doesn't stay consistent. In fact, it shifts in brightness periodically. This variability is a characteristic feature of red supergiants, reflecting complex internal processes. This eccentricity is no coincidence since Betelgeuse, as the star is called, is no ordinary star. Its enormous size and advanced phase of evolution set it apart from the multitude of stars in the night sky. Although to us it may appear to be just another star in the vast expanse, it is situated at a distance of more than 640 light-years from us. This distance, while immense, places Betelgeuse relatively close in galactic terms, making its study especially significant. At first, this figure may not seem impressive, but in reality, it represents a colossal distance. To illustrate this magnitude, let's imagine that we could travel at the speed of light. Even in that hypothetical scenario, it would take us over 640 years to reach Betelgeuse. Such a journey would span generations, highlighting the vast scales involved in space exploration. If we were to undertake such a journey in a spacecraft, even using our most advanced technologies, it would take us more than 12 million years to reach it. This figure far surpasses the entire history of human civilization on Earth. Such an endeavor would stretch far beyond our current technological capabilities and lifespans. Anyway, the faintness of light from Betelgeuse isn't simply due to the distance that separates us from it. The star's intrinsic properties also play a crucial role in its visibility from Earth. Betelgeuse is known as a throbbing red supergiant, which means that it is an old massive star that undergoes expansions and contractions. These throbs are driven by the complex interplay of nuclear fusion and gravitational forces within the star. During these cycles, its brightness can vary in the night sky, becoming more intense or dimmer. These brightness changes can occur over extended periods, ranging from 10 to many days. This dynamic behavior makes Betelgeuse an object of constant interest and observation. Amazingly, Betelgeuse can waver in brightness over a wide range. It can go from close magnitude 0.5 to reach 0 magnitude, making it very bright. These changes follow cycles, with the shortest being 185 days and the longest being 2,335 days. Such variations provide valuable data for understanding the underlying mechanisms driving these fluctuations. At certain times, Betelgeuse can become quite faint, which is called its minimum magnitude. In February 2021, its lowest minimum magnitude in years was reported, reaching a magnitude of plus 1.614. Although relatively bright, it is definitely fainter than how we normally observe Betelgeuse. This dimming event ignited widespread interest and numerous studies to unravel its cause. However, brightness isn't the only remarkable feature of the star. Betelgeuse is known for its distinctive reddish color, which is due to its cool surface with a temperature of around 3,500 Kelvin. This cooler temperature is a hallmark of red supergiants, standing out sharply from hotter blue stars. This temperature is much lower than the surface of our Sun, which reaches 5,500 Kelvin. This lower temperature means that Betelgeuse emits much less energy per unit area compared to the Sun. That is why, despite being one of the largest stars we know, it appears much dimmer. The enormous size of Betelgeuse, combined with its lower temperature, gives it its characteristic reddish shade. Betelgeuse is like a giant that is content with a low profile and doesn't need to flaunt its size to feel important. Its quiet glow in the night sky belies the immense energies at play inside. However, don't be fooled by its appearance. Betelgeuse is a very giant star that is around 20 times the mass of our Sun. This is one of the reasons why this star has been the subject of numerous studies over the centuries. Its massive size and evolutionary stage make it a significant object for understanding stellar physics. It has been a prominent object in the night sky and was first identified by the ancient Greek astronomer Hipparchus. Its name in Arabic means the Orion's armpit, reflecting its position in the constellation. Although not much could be known about Betelgeuse at the time, modern telescopes have enabled researchers to study this phenomenon in more significant detail. Advances in observational technology have opened new windows into the star's complex structure and behavior. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope, for example, has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gases and dust. These observations have allowed researchers to create models to understand the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter/Submillimeter Array, ALMA, a cutting-edge observatory located in Chile. ALMA has provided high-resolution images of Betelgeuse's surface, revealing details about its structure and behavior. These forefront instruments continue to enhance our knowledge of the stellar giant. One of the most beautiful discoveries made by ALMA is the presence of a broad plume of gas extending from the surface of the star. This plume is believed to be caused by throbs from Betelgeuse. These throbs can be explained by a process called convection, involving the rising of hot gas and the sinking of cold gas. This movement creates waves that travel through the star's atmosphere, making it expand and contract. This dynamic process adds to the star's variability and complex behavior. Thanks to the Hubble Space Telescope, detailed images of Betelgeuse's surface have also been obtained, revealing complex patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict how it might act in the future. Such detailed studies help refine our models of stellar evolution and supergiant dynamics. Moreover, Betelgeuse's surface is marked by dark spots, also known as star spots or magnetic spots. These areas on the star's surface indicate particularly strong magnetic forces. These regions, known as star spots, are cooler areas on the surface of Betelgeuse. This is because the star's magnetic field suppresses the flow of gas from the interior to the surface, creating a cooling effect. These spots can provide insights into the magnetic activity of massive stars. As a result, the spots appear darker compared to the rest of the surface. Betelgeuse's magnetic field is believed to be many times stronger than that of the Sun. This intense magnetic field causes the gas on the surface of the star to be trapped in loops or arcs, depicting regions of intense magnetic activity that are visible as star spots. These magnetic loops can extend far into the star's outer atmosphere. It is essential to note that the presence of star spots isn't unique to Betelgeuse, as they are also observed in other stars, including our own sun. The star spots in Betelgeuse are particularly interesting because of their size. They are several times larger than Earth and cover up to 20% of the star's surface, which is an incredible size. The presence of these spots suggests that Betelgeuse may have an active magnetic field, which,